Imagine our planet not as the blue marble we know and love, but as a giant white snowball hurtling through space. This isn't science fiction. This is the terrifying and fascinating theory of Snowball Earth. About 700 million years ago, our world was plunged into a deep freeze so extreme that ice sheets, possibly a kilometer thick, stretched from the poles all the way to the equator. So what could possibly cause such a global catastrophe? And more importantly, how did anything survive? The story begins with a planet in a very different state than today. The continents were clustered together in a supercontinent called Rodinia, mostly near the equator. This led to intense weathering of rocks, a process that sucks carbon dioxide, a key greenhouse gas, out of the atmosphere. With less CO2 to trap heat, the planet began to cool. As the ice caps at the poles started to expand, they triggered a runaway effect. You see, ice is bright white and reflects sunlight back into space. This is called the Albedo Effect. More ice meant more reflection, which meant less heat was absorbed by the Earth, leading to even colder temperatures and even more ice. It was a vicious cycle, a positive feedback loop that quickly spiraled out of control, locking the entire globe in a frozen embrace for millions of years. The evidence for this is literally written in the rocks. Geologists around the world have found strange layers of rock from this period. They find deposits called tillites, which are jumbles of rock and sediment dropped by glaciers. The shocking part is that these tillites are found in areas that were at the equator 700 million years ago. Even more bizarre, sitting directly on top of these glacial deposits, are thick layers of limestone called cap carbonates. Limestone typically forms in warm, tropical waters. Finding it directly on top of glacial debris is like finding a palm tree growing in Antarctica. The only explanation that fits is a rapid shift from an extreme ice age to a super hothouse world. So, if the entire planet was a block of ice, how did life not get completely wiped out? This is where the story gets truly incredible. Life didn't just survive. It found clever ways to hang on in a few secret refuges. The first was likely near volcanic hotspots on the seafloor hydrothermal vents. These deep-sea oases would have provided warmth and chemical energy, creating little pockets of life in the crushing dark. Another sanctuary might have been small patches of open water near the equator, sometimes called water belts, or even tiny pools of meltwater on the surface of the ice, stained by the intense equatorial sun. And finally, some simple life forms like algae could have survived within the ice itself, just below the surface, protected from harsh radiation but still able to get a little sunlight for photosynthesis. For millions of years, Earth was a frozen wasteland. So what broke the spell? The answer came from deep within the Earth: volcanoes. Throughout the entire deep freeze, volcanoes never stopped erupting. They continuously pumped massive amounts of carbon dioxide and other greenhouse gases into the atmosphere. But with the oceans covered in ice, the CO2 couldn't be absorbed. So, for millions of years, it just built up and up and up. Eventually, the concentration of CO2 became so high, perhaps hundreds of times higher than today, that it triggered a super greenhouse effect. The planet began to thaw, and once the process started, it happened fast. As the ice melted, it exposed the darker ocean and land beneath. This darker surface absorbed more sunlight, rapidly warming the planet and melting even more ice, the albedo effect in reverse. In what might have been just a few thousand years, the planet swung from a global icehouse to a sweltering hothouse. This dramatic thaw flushed huge amounts of nutrients from the land into the oceans, supercharging the surviving life. Many scientists believe this intense environmental pressure and subsequent nutrient boost set the stage for one of the most important events in the history of life: the Cambrian Explosion, a period of rapid evolutionary innovation when complex multicellular life suddenly appeared. The Snowball Earth wasn't just a catastrophe. It may have been the very event that kick-started the world we know today. Thanks for watching. If you found this journey into Earth's icy past as fascinating as I do, do you want to forget to hit that like button and subscribe for more deep dives into the history of our amazing planet? I'll see you next time.